All right, so I want to give you guys a couple of minutes on rates of change. So the idea for this thing is a little bit like that example we were talking about before where we had miles per gallon and miles per hour. Right? So say we had some kind of function like this. And let me exaggerate this a little bit so you can see. Okay. So I have some function like this, and maybe this is, I don't know. That's going to be kilograms, and this is going to be, uh-oh. Why am I hesitating? Because it fricked up?
Yep.
Yeah, it said something about negative kilograms. Ah, what the hell, we'll deal with it.
Space. Yeah, it just means you're jumping or something. Force. Vegetables.
Okay, so we're going to have kilograms as a function of vegetables, and this picture probably isn't going to make a lot of sense here.
Well, if you turn the weight upside down, you have a certain kind of weight. It might
Sure. Some reasonable interpretation about anti-vegetables and anti-kilograms might be required here. Okay? This is just an example. Don't sweat the reality too much.
Wait, so are we
Cool.
talking about vegetables which are evil and levitate then?
Sure.
All right.
Okay, so the idea, first things first, is just looking at this thing. If I kind of squint at it, it looks like lines, right? Yeah, like, really, from the back of the room, this probably looks a lot like, well, basically there's a line like this, and a line like that, and a line like this, right? Okay, that's great first blow information. This is really what we're going to do at first. We're just going to approximate, and we're going to say, okay, over here, what's happening? This thing is, yeah, it's rising, right? It's going up. So it's increasing. What about over there?
Still increasing.
Yeah, over there it's also increasing. You guys see that? In here, what's happening? It's decreasing. It's going down. Okay, so I should probably give good definitions for these things. So a function, say f of x, is increasing if what? Yeah, so with the units that we associated to this like silly picture, right? If more vegetables mean more kilograms, right?
For that one.
So it's increasing if bigger x's mean what?
More of the bigger f of x.
Yeah, bigger f of x's. Okay, see this? Really, this is bigger inputs make bigger outputs. Cool. So more vegetables make more kilograms. That's what it means to be increasing. So other things I could think about increasing are things like it's going up from what?
From its origin? From its original point?
How about as I read the graph from which to where?
Left to right.
Yeah. So it's going up from left to right. Or squinting at it results in a line with what?
Positive slope.
Positive slope. Cool. So let's modify this definition to talk about decreasing. So I'm just going to write decreasing right over the top of this in orange because it's basically the same thing. Sure. Do you want me to, is different colors better?
Yeah.
Blue? Okay. So instead of increasing, I want to define decreasing. Right, so how is decreasing going to be different?
If smaller x's mean smaller f of x's.
Careful. Bigger x's make smaller.
Okay.
And don't think about this in terms of absolute value. Think in terms of like actual numbers, right? So these are getting more negative, right? Maybe. They're going that way.
Okay.
Smaller doesn't mean coming into 0, it means going that way,
Okay.
right? What does going that way mean here instead of up? So we're going to go down from left to right. That's this guy, right? As I move left, the thing goes down. This is nice because I can read it in the same direction. Right? I can just say, okay, I'm going to move from left to right. And at first here we're going up, that's increasing. And then we're going to hit this high spot. And then we're going to start going down. That's going to be decreasing. But I can just read it straight across. You don't have to flip your directionality or anything. And squinting at it results in a line with negative slope. Cool? You guys with me on this?